A right circular cone and a right circular cylinder have equal base and equal height. If the radius of the base and the height are in the ratio 5:12, then the ratio of the total surface area of the cylinder to that of the cone is what? Okay, so the question is telling me that there is this cone and this is a right circular cone. What does this mean? It means that the height of the cone bisects the base of the cone. All right, so that is what the right circular cone is. And let's say the height here is h and the radius of this cone is r. Okay, and there is also a cylinder. This is also a right circular cylinder. That means the height of the cylinder bisects the base of the cylinder. All right, so and the question is telling me that the right circular cone and right circular cylinder have equal bases and equal heights. So if the height of the cone is h, then the height of the cylinder will also be h. Again, similarly, radius of cone is r, radius of cylinder will also be r. If the radius of the base and the height are in the ratio 5:12, we are given the ratio of radius to that of the height as 5:12. All right, then the ratio of the total surface area of the cylinder to that of the cone is what? All right, so first of all, we need to find out the total surface area of cone and the cylinder. So let's do that. So total surface area of cone here will be, now there is this circle, right? There is this circle. So first of all, we'll need the area of circle. So it will be pi r square plus the upper part of this cone. When we cut this up and open it up, we'll get a diagram that would look something like this. Okay, and this is the section of a circle. Now we know that the area to calculate section of the circle is pi r l, l being the slant height, right? L being this height, or we can say the radius, but it will make lot of complications, so we'll call it L. L is same as this slant height, right? Now what is this L? Okay, we don't need too many variables because it will make our example complicated. So we need to find out what this L is. So what we'll do is take this right angle over here. Okay, take this right angle. I'll draw it separately here. Okay, so this is the right angle. This is the L, right? This is h, this is h, and this is r. Okay, we need L. Now using the Pythagoras theorem here, we know that hypotenuse square is one side square plus other side square. So we get L square as h square plus r square, right? So taking square root on both sides, we get L is equals to under root h square plus r square. So we'll write it over here. So we get, let's take pi r common. Okay, pi r taken common, we are left with r plus L. So instead of L, we'll write under root h square plus r square. All right, so we have the formula for total surface area of cone here. Now let's calculate for cylinder. Okay, so total surface area of cylinder here will be, now there are two circles at the top, one at the top and one at the bottom. So we'll get area of two circles. So pi r square plus again pi r square. Now when we cut this up and open it up, we'll get something like this. All right, so this is L and this is B. So area of the rectangle is length into breadth. But what is this L? L is same as that of the circumference of this circle. So L is 2 pi r. This is the formula to calculate circumference of the circle. And B will be same as this height. So we get, instead of L and B, what we'll write? What we'll write? Sorry for that. We get 2 pi r square plus, instead of L, we'll write 2 pi r and into B. So instead of B, we'll write h. So what do we get finally? We'll get, let's take 2 pi r common, 2 pi r taken common, we are left with r plus h. All right, so this much is clear. Now we have total surface area of cone. We have total surface area of cylinder and we need the ratio of that. I'll just erase it. I hope this was clear to you. So we are asked what is the ratio of total surface area of cylinder to that of cone. So total surface area of cylinder to that of total surface area of cone. So let's write it over here. Total surface area of cylinder is 2 pi r plus h upon total surface area of cone pi r in bracket r plus underscore h square plus r square. All right, now pi r gone. Now we are left with this. Now if we remember, we are also given that the ratio of radius is to height is 5 is to 12. So what we'll do is substitute 5 for r and substitute 12 for h. So let's do that. So we get 2 in bracket r plus h. So 5 plus 12 will be 17 upon in bracket r. So instead of r we'll write 5 plus under root h square. So h square. So 12 square is 144 plus r square. So 5 square is 25. So we get 17 into 2. Okay, so we'll not multiply this. We'll just write it as it is as of now. We are left with 5 plus, now 144 plus 25 is 169 and 169 is square root of 13. Alright, so we have 13 here and 13 plus 5 is 18. So 13 plus 5 is 18. Now 2 ones are, 2 nines are. So we have our answer, which is total surface area. So total surface area of cylinder is to total surface area of cone is 17 is to 9. 17 is to 9. And this is our required answer. So here option D is the correct one.